Hi everyone. So when we come to the class 10 physics, we have four important concepts that hold in the science. In the physics, 25 marks are there. First one is electricity for 7 marks, magnetic effect of electric current 6 marks, light. There are two important concepts in the light, reflection and refraction, that is 7 marks. The human eye and the colorful world, this is 5 marks. So totally 25 marks will cover up in the physics section. So you have to focus very sincerely in these four chapters. So electricity already I started in my previous sessions. Now because of so many requests from the students, I am going to start the light chapter. There are two important concepts, reflection and refraction. So these marks in these, why I am saying these marks means because of the exam point of view. So first you focus these marks and then important concepts you can prepare well. But according to the knowledge level, you have to study each and every concept, each and every word, whatever will comes in your topic. Clear? Let's go to the refraction now. Let's go to the light chapter. Okay, now according to our syllabus, we can discuss about the light chapter. See here in the light chapter, there are two important concepts. One is reflection, another one is refraction. Through which objects we can get the reflection and refraction. So let's see now one by one. There are 7 marks in the chapter of light. Please be focused on this. See, before entering to this light chapter, we have to know some important things like what is mean by light. What is the importance of light? Without light, we can't able to see the objects. With only the light, which property of light will be the reason for the visible? So, which property of light is able to see the objects? So, that is called reflection. So, this reflection, through which object we can learn the reflection property of the light, in the sense spherical mirrors. Look at here, spherical mirrors. You know about the plane mirrors, right? Whatever our domestic purpose, we will use this plane mirrors just for the to look the image. Whatever the image, the real image will form on the plane mirrors. Let's see what about the spherical mirrors. There are two important mirrors in the spherical, that is concave mirror and convex mirror. So in these concave mirrors, how the reflection will occur and how we can see the images through it. And then in the convex mirror, how the reflection will occur, where the reflection will occur, what is its advantages. Both are very useful in our daily life. And then this is like this. Concave mirror, in the sense the reflection will happen inside. Reflection will happen inside, coating will be outside. You may observe in the homes we will use the small mirrors, in the sense one back side the coating, one layer will be coating layer it will be, and then other side refraction. So here reflection will be inside, coating will be outside. So in case of convex mirror, reflection is outside. So coating will be inside. That's it, the difference. Don't get the confusion between the concave mirrors, convex mirror, concave lens, convex lens. So clearly each and every step understand it. Here we are going to study the concave mirrors, how the reflection will happen here. And then convex mirror, how the reflection will happen here. Let's see, this is a little bit here reflection. This is a concave means reflection will occur. This is a spherical, right? Spherical. It is a curved thing. This spherical reflection will occur in a inside and then outside will be the coating. If convex means like this, reflection will occur outside. Coating will be this side. Clear? So let's look at how the reflection will happen on convex mirror and concave mirror. Observe both the diagrams. If possible, make a note of these two diagrams when entering to the reflection. Before this, you have to know this is the introduction part, how it will occur. When the light rays are falling on the surface, spherical surface of convex mirror, it will directly focus on focus. This is a principal focus. So it is diverging back. That means the reflection occurs in different ways. So we can call it as a diverging mirror. This convex mirror we are calling as a diverging mirror. Diverging mirror. Even it will forms, this convex mirror forms virtual and erect images. Erect images. Virtual means just when you are looking to the plane mirrors, if your right hand will looks like a left one, left hand will looks like a right hand, just invert. So reverse, that is virtual, and erect in the sense it is not a purely virtual, just it is looking like that. And then when we will come to the concave mirror, concave, the reflection will occurs inside, outside will be the coating. So it will, when the light rays are falling on the spherical concave mirror, it will reflect back to the focal point on the principal axis. So this we will call it as a converging mirror. Converging mirror. Okay, after looking about the convex mirror, concave mirror, how the light will reflect on these spherical mirrors, let's look at the what about the reflection. We are going to the definition according to your textbook. So under the light chapter, we are going to classify two properties of light. So we are not discussing about any scattering, diffraction of the light thing, only the two properties in your textbook, that is reflection and refraction. Reflection through the spherical mirrors and refraction through the spherical lens. Spherical mirrors. Concave mirrors and convex mirror. In refraction, spherical lens. Here concave mirror means like this. Convex mirror means like this. Inside reflection, outside coating. Here is in outside reflection, inside coating. Concave like this, double of this. Understood? If you want, make a note of these flowchart. It will be easy to understand whatever the concepts will come under the light chapter. After that, numericals also we have to solve. Once you understand the spherical mirrors and spherical lenses about the reflection, refraction of the light properties, after that this magnification formula, focal length formula, then we can go to the numericals. Make a note of this. Otherwise, take a screenshot of your mobile, in your mobile. Let's look at first what is meaning by reflection. Bouncing back of light on the surface of spherical mirror. Reflection means, make a note, how we can give the definition for reflection. Bouncing back of light in the same medium. Look at your same medium. We need only one medium for the reflection. Same medium on striking the surface of any object. So here I am saying the definition of reflection, not only the mirrors, whatever the objects. When the light is falling on a object, that object will reflect backs. So then we can able to see that object. Because of the property of light, we can see the objects through our eyes. Bouncing back of light in the same medium. Look at your same medium. If this is one medium, so for example, this is one object here. This is one object here. This is a medium. This is a principal axis. Then I will say all the components of convex and concave mirrors. I will say each and every one part to make you to understand better. So once the light is falling on this object, again it will reflect in the same path. So whatever this perpendicular line, this we will call it as a normal ray. This is a normal ray. This is a incident ray. This is a reflected ray. So bouncing back of light in the same medium means same medium. It is coming through the air. Again it is reflecting back to the air. On the striking on the surface of any object, when it is touching on any object. Clear? Now you are clear about the definition of reflection. Once again I am saying, bouncing back of light in the same medium and striking the surface of any object. Make a note of it. Again we will see the laws of reflection of light. If you can't able to write, take a screenshot from your mobile. Laws of reflection of light. Say, I wrote here one diagram. This is a medium. When the light is coming and striking on the surface of any object, again it will reflects back. So this angle of incident will be equal to the angle of reflection. Clear? So that is only the first law of reflection is the angle of incident, the angle of incident will be equal to the angle of reflection. Understood? Again, the second law, I told you about the normal ray. This one, the incident ray. Look at here, all the three rays. This is the normal ray, this is perpendicular to the plane of the object, and then this incident ray and the reflected ray. All the three rays are laying on a same plane, same medium. The incident ray, reflected ray and normal ray. Normal ray are lies on the same plane. See, these are the two important laws of reflection of light. They may ask for the 2 marks also. They may ask for 2 marks. So make sure that you understand or not. You can able to write with the image or not. Make sure that it will be important for 2 marks also. Otherwise, they can twist this question. They can ask in MCQ questions also. So let's look at how image will forms on the plane figures. The image formation on a plane figure. These are not important for your exam point of view, but if you know the concept, you can understand the numericals. So only I am explaining about the plane figure also. The image formation in a plane figure. So, properties of image in a plane mirror. Plane mirror. Plane mirror in the sense? No spherical. Whatever we will use at the homes, right? That one. So, some important properties. Please make a note. I am saying again and again. Don't listen blindly. Understand and write it in your notebooks. Image size is equal to object size. Whenever you are looking in front of your mirror, the size of the object, that means you, and then whenever you are looking through the mirror, both will be same, right? That's what image size will be equal to the object size. Image distance will be equal to the object distance. You have to know about this reflection on plane mirror also. Once you understood this one, after that this is the later version, spherical mirrors. How the reflection will forms on the spherical mirrors. There are two types. So first look at these properties, how the reflection will happen on the plane mirrors. First one is image size will be equal to the object size. Image distance is equal to the object distance. And then image is always erect and replica. Erect means replica. Image is always erect. Erect in the sense, however you are looking virtually, the same thing will occur through the reflection on that plane mirror. Means it's nothing but replica. Then its virtual image is always virtual. Virtual means just opposite. Right hand will looks like a left hand will looks like a right hand. Always virtual. And then image is also laterally inverted. Laterally inverted. That means straight reverse. That's it. These are the important properties of the light. When falling on the plane mirror, it will get reflection. So these are the important things you will get. So here, when we are looking these properties of the reflection on the plane mirrors, we can say the image, how it will looks in the sense, it will be the real image. Real image. And Virtual. Virtual means just whatever, however we are standing here, in the camera, my right hand is looking like a left, left is looking like a right whenever you are watching the video. That is the example for this plane mirror. Look at the question on the board, that if all the rays meet at a same point in a plane, how many rays are sufficient to find the image? Clearly observe whatever the introduction I given you about the reflection on a plane object. I am not saying, still I am not entering your concept, that is the reflection according to your textbook. Generally I am saying in your exam they may ask as a MCQ question also. This one is important. If all rays meet at same point in a plane, how many rays are sufficient to find the image? Generally you think, if this is an object, what I said before, if one ray is coming here, it is bouncing back, this is an incident ray, and then it is going back, that is a reflected ray. If you want to see any object, only two rays is sufficient. One is incident ray, another one is the reflected ray. So, if you understand this concept, you can able to answer this question. If all the rays meet at the same point in a plane, same point, both the rays are meeting at the same point on an object, how many rays are sufficient to find the image? There are four options I given: 3, 2, 1 and many. Don't get the confusion. If you want to see the object visible, object should be visible, there are two rays is important. One is incident ray of light, another one is reflected ray of light. So correct answer is the option B. Two rays are sufficient to find the image. Okay, now let's look at the components of spherical mirrors. Here, in the concave mirror, you know the reflection will be the inside. The convex mirror is reflection is outside. So here, the inside. See, look at here. This is a concave mirror. The reflection will happen inside. So this is the center of curvature. This spherical curve, what is there here? Spherical curve. This we will call it as a curvature. And then the total diameter of this spherical mirror, we will call it as a aperture. This total diameter we will call it as a aperture, but radius of this from the point of center of curvature to the pole, principal pole, we will call it as a radius of spherical mirror. And then this is the center of curvature. This is the pole. This is the principal axis. Principal axis. And in the same thing, here also the reflection will occur outside the mirror. Coating will be here. So this is the center of curvature. Whatever you are looking here, the spherical curve, this is called curvature of the convex mirror. This is the center of the curvature. This is the radius of the curvature. The distance between the pole of the curvature to the center of the curvature, we will call it as a radius. And then this is the pole, this is the principal axis. From both the concave mirror and the convex mirror, the components are the same. The first one is center of curvature. Center of curvature C. Second one is radius of curvature, capital R. Radius of curvature, capital R. Next, principal axis. This one, middle one, here. This is the principal axis. Then, this is inside reflection, this is outside reflection, and this is the pole. This is the pole of the mirror. Pole. P. there are four important concepts. Center of the curvature for both the convex and concave mirror. Center of the curvature of the spherical mirror. Here is the center. This is the center portion between the pole of the curvature, and the center of the curvature is F. And then one more is, this is a F focus. The distance between the center of the radius to the pole of the curvature, always this R is of this R. This is the radius of the curvature is double distance of the this focus. I'll say the relationship between the R and F. After first you look at these components of the spherical mirror, then we will go to the relationship between the R and F. G. Okay. Now relationship between the R and focal length F. I told you R means radius of the curvature. C means center of the curvature. I told you about the aperture. Aperture means the diameter of the spherical mirror is called aperture. Let's see here, from the distance from the center of the curvature C to the pole of the curvature, we will call it as a radius of the curvature. So the center portion from C to P is called F, focus, where the light will focus, then it will of reflected light will be focused at this point, right? So this is called focus, F. From the distance between this F focus to the pole of the curvature, we will call it as a F. That is the focal length, small f. So the relation here, the small f will be equal to the half of the radius. So R is equal to 2f. Always the radius of the curvature will be the double of the focal length. Clear? Let's solve about one problem on this. Let's solve the problem on this relation between F and R. Write down the problem. If if focus is located at 10 centimeter from the pole, what is the value of R? So you know the relationship between R and F. R will be equal to 2 times of focal length. Just it is very simple. The focal length they given, that is a 10 centimeter from the pole. Clear? So 10 centimeter. So radius of the curvature you are getting 20 centimeter. That's it. Thank you everyone for watching this. In the next class we will learn about the representation of images formed by spherical mirrors using radar.